So this is what we had for our homework yesterday, okay? Just to recap, similar triangles are two triangles that have the same shape. However, so they have exactly the same triangles, however they have different lengths. So for example, if that was 2, that was 4, if that was 3, that would be 6, if that was, 4, that would be 8. The triangle on the right is exactly double the triangle on the left. These are similar triangles, okay? Now, what we learned is that we have a two triangle system. Two triangles are thrown into one. Everybody happy enough with that? So what I have to figure out is what are the ratios, what's going on here. So I'm going to draw both triangles separately for this at the start. So I'll just draw this here like so. So that's the first triangle. So I'm just going to, actually that's not actually a half bad idea. I'll just leave that up there like so. And then the second one, this triangle here, the bigger one, the 2. Once again, I'll just drag that underneath for a minute, and then I have it to myself. So there is the big triangle and the small triangle drawn and put beside each other in separate diagrams. Okay. So I'll label them ABC, and the other one is AXY. So I have ABC, and then I have AXY. Now, what I know about ABC is that it has a gap of 20 to AB. What else does it have? B to C is 36. This one is 18. And that seems to be all what we know, isn't it? Okay. Now, gives me a key piece of information. It says A to X is what, guys? A to X is 3 times X big. A to X is 3 times X big. We've already used A to B as 20. So that piece of information, Sean, is we've used that part. We've used AY equals 18, and we've used BC equals 36. The only piece of information I haven't used is the blue piece there about AX being 3X big. Right? I'm going to prove they're similar though, okay? So I'm just going to make sure I'm definitely dealing with similar triangles. This angle is the same as this angle. For what reason? Corresponding. That's where the information about them being parallel to each other comes in handy. XY is parallel to BC. That means I'm allowed to use corresponding angles. I'm now using this piece of information as well. Then I can also say that one equals that one. And because once again they're corresponding angles. Everybody know what corresponding angle is? Basically the backwards F, or the same thing as a normal looking F, right? That's what corresponding angles is. Now, that means that the third angle is obviously going to be it's the same angle, so that means that these two triangles in question are in fact similar. Okay, next thing, 3AX. I haven't got a clue what AX is, so I'm going to make up a letter to represent it. Okay? 3AX equals 3XB. So I'm just going to make up a letter M. Okay? I'm going to let XB be equal to M. Is everybody happy enough with that? So that's the length M. And then what it tells me is that AX is 3 times XB. So that length there could be 3M, which makes the full thing 4M. And that would mean 4M equals 20. And this means M equals 5. This means XB is 5 and AX will be 15. Okay, exactly. AX is going to be 15 and XB equals 5. Now I have a bit more information to fill in. I can say that's 15 and that one there is 20. Now I can calculate how much bigger the triangle is on the left compared to the triangle on the right. Reason being, this side here, the 15 and the 20 are corresponding sides. They're in between the black angle and the blue angle. So what's 20 divided by 15? 20 divided by 15 is 4 over 3. Two ways to look at it. You can multiply the small triangle by 4 over 3, and that turns it into the big triangle. Or you can multiply the big triangle by 3/4, and that will turn it into the small triangle. So very easy. What's 36 multiplied by 3/4? 27. Now you have all the information you need. Okay? So that means that, let me see. We have to find out what YC is, don't we? Everybody happy with YC? Now, we know that that's, let me see. Oh yes, one more thing. Does everybody understand how I multiplied 36? Does everybody understand how I multiplied 36 by 3/4 to get 27, yeah? How do I turn 18? What do I need to do with 18? Multiply by 4 over 3, which will get me 24. Okay?
Is 4 over 18 how much bigger the other triangle is?
4 over 3 is how much bigger the other triangle is. I divided 20 by 15 and got 4 over 3. I only took it down a second ago. Okay? So, that's 24 and that's 18, okay? Now guys, if you look at your original diagram, I've now claimed that that full length is 24. What does that make the length YC? 6, because 18 plus 6 is 24. What does that make AC? Did we work out AC yet? We already got that as 24. And finally XY, 27. That's it. They're actually not that bad once you break them up into two similar triangles, yes?
When you were getting XY,
Yeah.
did you just know that you knew that triangle was 3/4 the size of the bigger one?
Yeah. When I went back all the way, if I go all the way back, okay, the first piece of information I really got was I proved I used, see this part in blue here. I proved that I decided to call X B M, and therefore X to A has to be 3M. David, are you paying attention?
I know, I got all that.
Okay, and just showing you where I linked it in. So 4M equals 20, and then we found out that M was 5. Now once I found out that M was 5, I then found out that that was 15. And by linking the 15 to the 20, I found out that this triangle here is 4 over 3 times bigger. And then hence by multiplying 36 by 3/4, I could then figure out that that was 27. Okay? Now, this one here, guys, okay, it looks really difficult, but it really isn't. The first thing it's asked me to do is explain why they're similar. I want to explain why the big triangle on the left is similar to the triangle on the right. Dennis, how do I do that? I want to prove that it's similar to that one, similar to that one. You don't need to calculate the angles, you just need to prove they're the same. So I'm going to go say the red one's the same as the red one. Why? Angle ACB is equal to your right. Angle DCE, reason vertically opposite. Okay? I'm going to pick another triangle in both of them. I'm going to pick the angle CAB. What's CAB the same as? CED. What's the reason? It's given. And therefore the third angle is the same. So then you can say that one equals that one. Excuse me. That one equals that one. That's the angle ABC equals the angle CDE. Reason?
Corresponding.
No, three angles must add up to 180. No, it's three angles equals 180. So you proved that that angle and that angle are the same. They're both contained within triangles. So it means the third angle has to make it add up to 180.
Yeah.
Okay? Now, done. Calculate D to E. Excuse me. Calculate D to E. What I suggest you do, once again, is I suggest you draw them both separately and then rotate them around so they both look the same. So what I just spend, there's another way of doing it, right, without having to draw them around, is you just pick a side that's between both angles, okay? So as an example, you want to calculate D to E, don't you? Okay? Now, what have I told you, and can anyone in the class explain why I'm saying these two sides are corresponding? I'm going to say 6 corresponds to 4. 6 in the big triangle is the equivalent side to 4 on the small triangle. Why did I say that? It's in between green and red, and the other one's in between green and red. This means that if I divide 6 by 4, it means the triangle on the left is 1.5 times bigger than the triangle on the right. Or vice versa. If I divide by 1.5, I turn the triangle to the left into the triangle on the right. So, what do I need to divide 3 by to get DE? 3 is in between the green and the dots. So divide it by 1.5 and you get 2.
How do you know that it's 1.5 for DT?
Because 6
Divided by 4.
is the equivalent side to 4, so it's the left triangle is 1.5 times bigger than the right triangle.
Okay,
Yeah?
yeah.
And therefore, if I divide the big triangle by 1.5, I turn it into the small triangle. Okay? What about the next one then? AC. A to C is this one here. It's equivalent to 5. So 5 needs to be 1.5 times bigger. So 5 multiplied by 1.5? 7.5. Okay. Okay, you guys have a go at this one.